please share the screen?
ശാലിനി മാഡം ലെഫ്റ്റ് ആയി പോയി. ഞാൻ ഒരു ഇൻട്രൊഡക്ഷൻ പറഞ്ഞോട്ടെ.
പറഞ്ഞോളൂ സർ, ഞാൻ അൺമ്യൂട്ട് ചെയ്യാൻ വേണ്ടിയിട്ട് എടുത്തതാണ്.
ഒരു ഇൻട്രൊഡക്ഷൻ പറഞ്ഞോട്ടെ. സിവിൽ എഞ്ചിനീയറിംഗ് കൺസൾട്ടൻസി രംഗത്ത് ഡിസൈൻ കൺസൾട്ടൻസി, PMC കൺസൾട്ടൻസി, ക്വാളിറ്റി കൺട്രോൾ, എഞ്ചിനീയേഴ്സിന്റെ കപ്പാസിറ്റി ബിൽഡിംഗ് എന്നീ മേഖലകളിൽ പ്രവർത്തിച്ചുകൊണ്ടിരിക്കുന്ന ഒരു സംഘടനയാണ് നമ്മുടെ ടർട്ടിൽ സ്മാർട്ട് സൊല്യൂഷൻസ്. ഇന്ന് എഞ്ചിനീയേഴ്സിന്റെ കപ്പാസിറ്റി ഡെവലപ്മെന്റിന്റെ ഭാഗമായിട്ട് LSTD എഞ്ചിനീയേഴ്സ് അസോസിയേഷനും ഹൈവ് ടെക് ബിൽഡേഴ്സും ഇന്ത്യൻ കോൺക്രീറ്റ് ഇൻസ്റ്റിറ്റ്യൂട്ടുമായിട്ട് ചേർന്ന് നമ്മൾ ഒരു പുതിയ ഒരു സ്മാർട്ട് ടോക്ക് സീരീസ് എന്നൊരു സീരീസ് എക്സ്ക്ലൂസീവ്ലി LSTDയുടെ എഞ്ചിനീയറിംഗ് സ്റ്റാഫിന് വേണ്ടി നമ്മൾ ആരംഭിച്ചിരിക്കുകയാണ്. തദ്ദേശ സ്വയംഭരണ സ്ഥാപനങ്ങളിൽ പ്രവർത്തിക്കുന്ന എഞ്ചിനീയറിംഗ് വിഭാഗത്തിന് വേണ്ടി വളരെ ആനുകാലിക പ്രസക്തിയുള്ള ഒരു വിഷയമാണ് ഇന്ന് നമ്മൾ കൈകാര്യം ചെയ്യുന്നത്. ഈ വിഷയത്തിൽ വളരെ അനുയോജ്യമായ ഒരു സ്പീക്കറെയാണ് നമുക്ക് ലഭിച്ചിരിക്കുന്നത്, ഡോക്ടർ ശാലിനി മാഡം. അതുപോലെ ഇന്ന് നമ്മുടെ ഒരു വിദഗ്ധ പാനൽ ഡിസ്കഷന് വേണ്ടി ഇവിടെ എത്തിയിട്ടുള്ളത് നമ്മുടെ LSTD CE. അദ്ദേഹം ട്രെയിനിലാണ്, എന്നാലും അദ്ദേഹം സന്ദീപ് സാർ അറ്റൻഡ് ചെയ്തോളാന്ന് പറഞ്ഞിട്ടുണ്ട്. നമ്മുടെ വാട്ടർ അതോറിറ്റി CE ഉണ്ട്, നമ്മുടെ ഹൈവ് ടെക്കിന്റെ സാരഥിയും ICI ചെയർമാനും നമ്മുടെ തിരുവനന്തപുരം സെന്ററിന്റെ ചെയർമാനും നമ്മുടെ പഴയ DCയുമായ അൻവർ സാറുണ്ട്, അസോസിയേഷൻ ഓഫ് എഞ്ചിനീയേഴ്സിന്റെ KT സാജനുണ്ട്, നമ്മുടെ വാട്ടർ അതോറിറ്റിയിലെ എക്സിക്യൂട്ടീവ് എഞ്ചിനീയർ ശ്രീ രാജേഷ് ഉണ്ട്. ആൻഡ് വി ഹാവ് സ്പെഷ്യൽ ഇൻവൈറ്റീസ്, വെരി പ്രഷ്യസ് സ്പെഷ്യൽ ഇൻവൈറ്റീസ്, ഡോക്ടർ ലിനി ദേവ്, അസിസ്റ്റന്റ് പ്രൊഫസർ NIT പട്ന ഉണ്ട്, ശ്രീ എഞ്ചിനീയർ ലോകേഷ് TR ഇൻഫ്രാ സപ്പോർട്ട് മാനേജിംഗ് ഡയറക്ടർ ഉണ്ട്. നമുക്ക് നല്ലൊരു പ്ലാറ്റ്ഫോമാണ് നമുക്ക് തുറന്നു കിട്ടിയിരിക്കുന്നത്. ഞാൻ ഒരുപാട് ഇൻട്രോ പറഞ്ഞ് ദീർഘിപ്പിക്കുന്നില്ല. ഇതിൽ സന്നിഹിതരായിട്ടുള്ള എല്ലാ വിശിഷ്ട വ്യക്തികളെയും ഞാൻ സ്വാഗതം ചെയ്യുന്നു. അതുപോലെ ഇതിൽ സന്നിഹിതരായിട്ടുള്ള എല്ലാ എഞ്ചിനീയർമാരെയും ഞാൻ സ്വാഗതം ചെയ്യുന്നു. വെൽക്കം ഡോക്ടർ ശാലിനി മാം.
Thank you, sir. Am I audible?
Yes, ma'am.
Topic for today's presentation is control low strength material, how to optimize the road utility trench rectification with this technology. As we all know that these utility agencies such as water authority, then sewage, underground drainage, then electricity cables, telecommunication lines, gas lines, etc. They have various degrees of authority to install these lines within the right of way of our that they do not create any inconvenience to the road users. So they can accommodate the utility in urban areas in either, as you can see in the figure, open trench or ducts. Only existing roads, if it is beneath the existing roads, they can give a duct, or during new road construction, they can provide a duct. So these are the available technologies. Also, in case of heavy traffic, and they can do one thing is they can push an RCC precast block below, with a precast RCC block below the road in that embankment. So these are some of the solutions in which methods in which they utilizate it in the right of way of our road. So ARC guidelines specifically mentions how these need to be installed and what is the location for each agency or each utility, or also the depth of installation specific to different agencies. This is given so that is occurred, also to safeguard them from any superimposed load. The depth, what IRC tells is at least a 0.6 meter depth below only that the bottom of the trench should be there. That is a lowest, and it can exceed to more than 1 meter depending on the type of a utility. So this table shows that the insulation depth for different utilities is different, so that there is no cross connection. Like when we have to dig it in, when we have to give a cross connection across the road or anything, so these should not be obstructed. So that is why they have given some level of different levels of location. So once we dig a trench, once these utilities are laid off in the trench, this trench needs to be filled with sand or any granular material. But while filling, we should make sure that it is saturated and it gets compacted to the modified Proctor density. Also, above this granular layer, we place the sand or the other granular material filling is usually till the subgrade level, and above that, whatever is the existing road condition, prevalent condition, whatever layer is there, base, sub-base, and the bituminous layers, those exactly we have to place so that there is no difference which can occur. So, and this level of the reinstated trench shall be flush with the adjacent rope. If it is not so, then it will give a discomfort to the riding, for riding. So, and also any neglect in the proper compaction or the selection of granular material can lead to many hazards or distresses. Also subsidence in that area alone, which again can cause serious issues. The IRC guidelines tell that the depth of fill, if it is greater than 450 mm below the crust, then you can fill it with entire that trench with the sand or a granular material. Or if the excavated trench material available is of similar quality, you can use that. But make sure that it is properly compacted by ordinary power roller, heavy plate compactor, or a small walk behind. If the depth is greater, make sure that it is mostly granular material which you are filling. Also, depending upon the level and location, each layer should be compacted for the required criteria, similar to that of embankment and subgrade, which is given in IRC 36. Deep and narrow trenches, it's very difficult to compact if the width is not sufficient for a ordinary roller to pass over. So we use small compactors such as plate compactor, frog hand compactor, or some small walk behind roller. നമ്മളുടെ റോഡിൽ ട്രാഫിക് ഫ്ലൈ ചെയ്ത് കഴിയുമ്പോൾ അൺഈവൻ ആയിട്ടായിരിക്കും വരുന്നത്. പിന്നെ അതേപോലെ അതിന് ഡ്രെയിനേജ് ഫംഗ്ഷൻ നടക്കില്ല. അങ്ങനെ ഓരോ ക്രൈറ്റീരിയ നമ്മൾ മീറ്റ് ചെയ്യണം. ഇത് ഇട്ടതിനു ശേഷം if there is any settlement either due to traffic or rain, you need to correct it. If once you have leveled it, then you do not leave it and go. If there is any correction required in the future, maybe once the traffic flies over it, you can see some small subsidence or settlement. That also need to be corrected. Then once granular materials and the bases are provided, provide bituminous surface and apply some tack coat so that there is some bonding between the old and new surface. So this is an example I had taken from the water authority side, and they're putting granular. This is typical how they are doing, and they have done it well. Only problem is if the material selected or the compaction is not proper, then this may not look like this after flying of traffic. Here you can see they have filled with granular material, then they have applied bituminous layers and then given proper compaction, and the entire area is flush with the road. But if it is not properly done, okay, this is another case. That is one case if the compaction is not proper. This is another case when you have many pipes. See, you can see in this picture, there are many pipes. So between the pipes and below the pipes, it may not be possible for the entire voids to fill between the pipes and below the pipes. So that compaction between the pipes, that also need to be carried out. Here you can see a person carrying a rod and damping it and compacting it. So this, in such cases, sometimes it becomes difficult for proper compaction to be ensured, and there can be chances of some uneven settlement. Lead to many problems, such as you can see that where the drainage was, that there is some kind of subsidence here, and then if that water can stagnate over it, and then it can lead to serious issues like low water logging, and future also some kind of hazards can also happen. So these are mainly because some of the trenches are very deep and narrow, and it is inaccessible for the proper compaction to happen. So if we compromise on the compaction or the material, then we can see that a lot of distress can happen. So another road in Trivandrum itself, by looking into the picture, it may not be visible that much, but there is some kind of curved surface occurring just below where the water line was placed along the entire road stretch. When the vehicle passes, you can feel that vibration, and when we can see that the vehicle is moving in a discomfort manner. Similarly, and when the rain started, around some places where the compaction was not proper, potholes were observed. So IRC 98/2023 specifies another method also. It suggests another method where this method is suitable, where the trenches or the filling of the compact material is not proper, and these trenches are inaccessible places are also there in these trenches. So that alternate method is to use a flowable fill or a controlled low strength self-compacting cementitious material. This do not need any kind of compaction because it is in a flowable nature. Once you pour it, it just gets, that hole gets just filled, and its specifications are there which needs to be followed. This US Bureau, they have started using it in 1964, and but slowly we are picking it up in India also. So this is another method which most of us are not familiar, and this is given appendix. So this can be an alternative solution. So what is controlled low strength material? Controlled low strength material is a weak runny concrete mix used for backfills or utility fills. It is mostly suitable when the places are inaccessible and the proper compaction by any other method is not possible. So this fill should be in a flowable condition. It should pour like a grout or a lean concrete mix. So it will go and fill all the voids, and then it should set harden within some specified time, and also have a minimum compressive strength. In the case of compressive strength, maximum compressive strength which the code or as per application they suggest is, it should be less than 8.3 MPa. So that is for all the applications. We say that it need not be very high like our normal concrete. We need only very less strength. So the mix selection depend on the two criteria. One is the flowability, that when placing the mix, it should flow and fill the voids, and then the UCS. Most of the application, that strength is between 2.1 MPa to 8.3 MPa, and for excavations, like when the utility we need to access the utility at some later stage and we need excavations, then we should make sure that the long-term strength is less than 0.7 MPa if you want to excavate manually. But if you have some machineries like backhoe and all, you can excavate, go till 2.1 MPa. So beyond that, it is not possible to excavate and it is very difficult. It may create damage to your utility even. So this is how it is done. You pour it and then it goes. Initially, your trenches like this, you need to have utility here. See, it is in such an uneven shape, or because of some other adjacent structure, we are unable to in such a manner so that, and you can keep your, and you can fill it by boring. So there is no problem of compacting this area if any structure is there. So the basic application is for all the utility, and it is an actually a replacement to granular fill. So wherever this granular fill is not readily available and we need to transport it from some other places, which will cause lot of cost, like the transportation charges as well as the material charge. So in such cases, then any other backfilling pipelines, abutments near retaining walls, near to the bridge abutments is another area where this is a more suitable method for filling the holes. Then inaccessible locations, underground storage tanks. These are some of the examples where we can use the lesson. So this is how in granular fill what the code suggests is we place in different lids, different around at least 75 mm or the other thickness, and then we compact it. This we pour it. Here also you can pour it at stages by giving different lids. And since it is self-leveling, do not require any compaction. And the material we typically use are a mixture of water, cement, fine aggregates such as sand, whatever fine aggregate is available. If now sand is not available, you can use quarry dust, quarry waste, any other foundry. Recycled materials also you can use. Many industrial wastes are being used as a fine aggregate for this mix, because if they have some pozzolanic activity, then it is much better, because it will react with cement and water, and further hydration will occur, and we get more cementitious materials for the strength gain. Mostly we are looking into the strength gain. Also, that the strength gain should not be too high so that the material cannot be excavated. So the material selection, what we need to mostly take care is that the cost. Suppose we have earthen material or the backfill material readily available, we not go for CLSM because it will be more costlier compared to the locally available solution. Only in cases where that it is highly inaccessible, we can go for CLSM. Also, the savings is mostly seen in the labor for placement and compaction, because we don't require any labor for compacting or for placing. We just pour it from the plant, the truck or the ready mix plant. Then depend on the specific application, the materials should be chosen. The material criteria, mainly the mix criteria, we select based on flowability, strength and excavability, and then density. So the materials are Portland cement, saving any cement type which is mentioned in the codes, any grade, 53, 43, 33, whichever satisfies can be used. That amount of cement we usually 1 to 5%, because we do not need that much high strength. We need only less than 0.7 or maximum 2.1 in case of our utilities, where we need to excavate at some other point. If we do not need to excavate, we can go further beyond 2.1. And usually the strength, we also check the strength of the soil surrounding that trench. So usually the same compressive strength we give as the subgrade soil. So cement, so because we need only 1 to 5%, we use around 60 to 90 kg per meter cube. Then for other pozzolanic materials like fly ash, GGPS, then for other bottom ash, mini pond ash, different kind of ashes that can be used. These are suggested because they have posthlanic activity. It is a fine aggregate as well as a alternate to cement with reaction with water or the cementitious material such as cement or fly ash or any other posthlanic material. So they should be sufficiently fine grained so that it flows, the material flows. Also, the total quantity of aggregates is around 1500 to 1700 kg. So water is another uh, um, requirement so that we have sufficient flowability. The water cement ratio should be mixed, selected depending on the flowability and strength and segregation. So then some admixtures are also being used. These admixtures so that this can be some improvement in the volume of the volume of the CLSM, also to provide improved workability, reduced shrinkage, less bleeding, minimum segregation, and lower unit weight. So this also helps in extending the setting times. So extra cement or early setting admixture may be added if required. Then the properties of the flowable film, basically it depends on the proportion, mixed proportion, the amount of materials from each category, how much we take and how much flowability at it. Usually we restrict the flowability 200 to 300 mm. Then cement ratio, water cement ratio is another criteria. So while placing the CLSM in the field, it should be in a flowable condition, and those properties, while placing whatever properties we call it as plastic property, which is related to transportation placing of the field. Also, in service properties after it hardens, what are the properties which we need to make sure it has so that it can work properly. So it is these are all affected by the mixed proportion. So the plastic or the wet properties, that is during transportation and placing, that we should take care is flowability, segregation and subsidence, hardening time, and pumpability. So flowability, either by slump cone, grout flow, or flow cylinder method we can use. So this is how you measure the flowability, both direction, perpendicular direction, what the slump dia, you can just measure and then find out. It should not be than 200 or more than 300. Less than there would be flow. The if water is higher, then what happens is it comes out as a bleed water. So this is also not allowed, and the code restricts less than 5%. Along with IRC 98, we have ACA, American code is also there, that American Concrete Institute 229R is another, the R is a code which we follow, which gives all the standards which need to be followed to check the testing procedures, as well as all these whatever I have shown in the shown regarding CLSM is given in the code. Hardening time. So you can see these are different trenches they have made to study trial mixes. So based on this is how they have done it in the field to actually study which mix which they can use. Either laboratory or field trials which we can try out, and then we can select the suitable fit. So hardening time, approximate time need to be given for the mix to set, that is from flow condition to rigid state. So it depends on the rate of bleeding as well as cementitious material in the mix. And hardening is usually measured similar to concrete with the penetration test or the Kelly ball apparatus, and it takes generally 3 to 2 hours. Sometimes it can even happen within 1 hour. So, and these are the factors which affect the hardening: the aggregate size and shape, quantity of cementitious material, the proportioning is very important, and the water in the CLSM, temperature, environmental condition, etc. And pumping, some equipment such as the same equipment which we use for concrete pumping is can be used for this material also, and void should be adequately filled with the particles to provide cohesiveness and stability for transport through the pressurized compliant without any segregation. This we need to make sure that there is no segregation, and also make sure that there is some kind of continuous flow is to be maintained. Otherwise, it gets stuck. And also make sure that pumping pressure is not that high, because it can cause loss in air content and reduce the permeability. So this till now we have the placement properties were discussed, that is while transporting and placing. These are the properties, that is in service properties, are the properties of the mix during its service period, that is after it gets hardened. So they are compressive strength, density, hydraulic conductivity, compressibility, settlement, excavatability, and shrinkage. Excavatability depends on the compressive strength, that it should be less than 0.7 MPa at 28 days or long-term strength, so that the mix can be excavated using pickaxe or light equipment. And if it is less than 2.1 MPa, we can use some JCB or black ore to excavate the CLS mix. But also the hydraulic conductivity, the code says should be between 10 raised to minus 4 to 10 raised to minus 5 centimeter per second, similar to our compacted granular. See, this actually act as a granular fill. Even though we see it as a concrete mix, it functions as a granular mix. So whatever properties which the granular fills are should attain, that all properties with this flowable fill also should attain during its service property. It acts as a soil only. So the density, while placing, because of the presence of aggregate, fine aggregate, the usual range of density in this mix is 1840 to 2300 kg per meter cube. But if we are not adding fine aggregates, it is just like a mortar. We add only the fly ash, cement, and water, then it comes around 1400 to 1600 kg per meter cube. So this depends on the proportion of the materials in the mix. Also, density can be maintained by taking care of the lightweight aggregates. For easy workability and pumpability, these values are put. We need to make sure that it is workable, and pumping is also possible. If it is highly dense, then that it may not be that workable, or pumping also we can have some issues. So in order to maintain this density only, we use lightweight aggregate. That is why most of the cases fly ash or any other kind of recycling materials is preferred. And even if some amount of shrinkage cracks are seen, it will not affect the performance of the CLSM, just like our but in case of concrete, if some shrinkage cracks or tension cracks are seen, then it can affect the performance of the pavement. But this, because it just fills the void, and it acts as a support. So usually that some amount of shrinkage cracks will not affect much its performance. Then excavatability, as I said, it is very important. Sometimes what will happen, we add more cement, we add more fine aggregates, the compressive strength becomes more than what is required. In such cases, what happens is it becomes very difficult to excavate. And then when we have to, if there is some leakage, or if there is some kind of widening happening and we need to relocate the utility, it becomes very difficult. So make sure that strength do not go beyond what is required. In order to show that we have we have done it properly, we may increase the strength, but that also will lead to harm. So the strength should be maintained. And there is another criteria, that is removability modulus, which depend on the dry density and the 28-day compressive strength. It should be less than 1. This relation is given in the ACI 229R. So if this is maintained, then we can see that there is chances of excavating the material. Then the cement and class of fly ash. ഇതിന്റെയും കൂടെ നമ്മൾ നോക്കണം. ഇതിന്റെ വെയിറ്റ്സും നമ്മൾ ഓരോ മെറ്റീരിയൽ ആഡ് ചെയ്യുന്നതിന്റെ വെയിറ്റും അത് ആഡ് ചെയ്യുന്ന പ്രൊപ്പോർഷനും എല്ലാം നമ്മൾ ശരിക്കും നോക്കണം. അതിന്റെ കാൽക്കുലേഷൻസും സാമ്പിൾ കാൽക്കുലേഷൻസും നമുക്ക് കോഡിൽ കാണാം. നമ്മൾ സാധാരണ ഒരു കോൺക്രീറ്റ് മിക്സ് ഡിസൈൻ ചെയ്യുന്ന പോലെ ഇതും ചെയ്യാം. മിക്സ് പ്രൊപ്പോർഷനും മിക്സ് ഡിസൈൻ വളരെ ഇമ്പോർട്ടന്റ് ആണ്. മിക്സ് പ്രൊപ്പോർഷൻ ഞാൻ പറഞ്ഞ പോലെ ഇതിന് ഈ ഓരോ ഐറ്റം നമ്മൾ എത്ര പെർസെന്റേജ് ആഡ് ചെയ്യണം, എങ്ങനെയാണ് ആഡ് ചെയ്യേണ്ടത്, അതെല്ലാം നമ്മുടെ IRC 98 കൊടുത്തിട്ടുണ്ട്. അപ്പൊ ആദ്യം വെള്ളം ആഡ് ചെയ്യണം, പിന്നെ അഗ്രിഗേറ്റ് ആഡ് ചെയ്യാം. ഇത് മിക്സ് ചെയ്യുന്ന സമയത്ത് ഇത് രണ്ടും എല്ലാം ആഡ് ചെയ്ത് ഒന്ന് ചെറുതായി മിക്സ് ചെയ്ത് പിന്നെ സിമെന്റ്, ബാലൻസ് അഗ്രിഗേറ്റും ബാലൻസ് വാട്ടറും ആഡ് ചെയ്യണം. കാരണം നമ്മുടെ ECLSM M2 to M8 within this range only it will be there. So this is another calculation. അത് ACI 229R കാണിച്ചിരിക്കുന്നതാണ്. ഓരോ വെയിറ്റ് എടുക്കുകയാണെങ്കിൽ ഇത്രയും ഇതാണ് ഇതിന്റെ റേഞ്ച്. മൈനഗേറ്റ് സാധാരണ നമ്മുടെ ഈ മിക്സിന് വേണ്ടത് ഈ റേഞ്ചിലാണ്. കൂടുതലായാലും നമുക്കത് CLSM മിക്സ് വർക്ക് ചെയ്യാൻ നമുക്ക് ബുദ്ധിമുട്ടുണ്ടാവും. ദാറ്റ് ഇസ് വൈ ദിസ് റേഞ്ച് ഇസ് കെപ്റ്റ്. ഓൾസോ ദ ഡിഫറെന്റ് കാൽക്കുലേഷൻ ഒരു ക്യൂബിക് മീറ്ററിൽ എത്ര സാമ്പിൾ, ഒരു സപ്പോസ് നമ്മൾ ഇത്ര സിമെന്റ് ഇടുകയാണെങ്കിൽ അത് എത്ര ഉണ്ടാവും, വോളിയോമെട്രിക് പ്രൊപ്പോർഷൻ കാൽക്കുലേഷനും കോഡിൽ കാണിച്ചിട്ടുണ്ട്. ഓൾസോ ഇനിയിപ്പോ നമ്മൾ എടുത്ത സാമ്പിൾ മിക്സ് പ്രൊപ്പോർഷൻ കറക്റ്റ് ആയിട്ടില്ല. That proportioning, how do you find out? Based on these properties. So if it is too low, the rectification also is given. What all rectification methods we have to adopt if our strength is too high, too low, stability and slump. That is probability. If both cases, what to be, how we can rectify the mix. That is also given. Now placing, we can see that it can be placed using the tubes. Then transportation from the plants, we can load it to the ready mix concrete drums, and then we can or through trucks, and we can transfer it to the site using the tubes. So ready mix concrete trucks, patching plants, concrete mixers, puck mills, ഇതെല്ലാം നമുക്ക് യൂസ് ചെയ്യാം. ഇതെല്ലാം നമുക്ക് ഇവിടെ ഉള്ളതാണ്. ഇത് ട്യൂട്ട് അല്ലെങ്കിൽ കൺവെയർ ബെൽറ്റ്സ്, ബക്കറ്റ്സ് എല്ലാം വെച്ചിട്ടാണ് we pour it in that. And then since there is no vibration and compaction to it, it gets self-leveling, self-compacting material. Also curing concrete അത്ര വേണ്ട, പിന്നെ അത് സെറ്റ് ആവും. നമുക്കത് കണ്ടിന്യൂസ്ലി ഓർ ലിഫ്റ്റ്സ് ആയിട്ട് പ്ലേസ് ചെയ്യാം, either in different layers or continuous. So how do you control quality control? നമ്മൾ ഇതിന്റെ ഫ്ലോവബിലിറ്റി നമ്മൾ ചെക്ക് ചെയ്യണം, whether it is flowable, പിന്നെ വെയിറ്റ്, യൂണിറ്റ് വെയിറ്റ് ചെക്ക് ചെയ്യണം, ആൻഡ് മൗൾഡ് ട്യൂബ് molds എടുത്തിട്ട് we have to find the strength also. These three things we can check in the field for the CLSM mix. Also, if suppose you don't have the sufficient quantity, but you need to fill the bottom of a trench and fill the voids below the trench, you can even do this kind of calculation, like different depths, full depth or partial, or just below the pipe, so that rest, if you have the granular material available, you can use. So these kind of calculations also can be done, and then these are some of the field tests, and this is an example of providing a CLSM at IIT Madras. What are the advantages? It is we getting this technology already in IRC 98 2023 and 2011, and Appendix 3, this method is suggested where there is scarcity of compacted granular materials for compaction, or there is inaccessibility to this trench. And other guidelines, American standards are there, because they have been using it continuously for past 50 years. We can use that. And I would like to acknowledge Professor Veeraraghavan, Assistant Professor Dr. Lini Dev, then Engineer Lokesh, Executive Director Infra Support, and my office, KCST NATPEC, which allowed us to conduct research in the CLSM. So, thank you all.
Dr. Shalini in NATPEC. We thank Dr. Shalini ma'am for sharing your experience. We hope your extended support in this field. Thank you, ma'am. Thank you very much.
Thank you, sir. Yeah, always.
Thank you. Now, let us start a panel discussion. We have our Chief Engineer LSDD Sandeep sir with us. I hope that Sandeep sir ഉണ്ടോ? സാർ ഇടയ്ക്കുണ്ടായിരുന്നു. അപ്പോൾ ഓക്കെ, സാറ് ഏതാണ്ട് ട്രിവാൻഡ്രം എത്തുമ്പോഴത്തേക്കും സാറ് കയറുമായിരിക്കും. നമുക്ക് നമ്മുടെ ബഹുമാന്യായ വാട്ടർ അതോറിറ്റി ചീഫ് എഞ്ചിനീയർ ഉണ്ട്, സുരജ മാം ഉണ്ട്. മാഡം കേൾക്കാമോ? സുരജ മാം?
കേൾക്കാം.
മാഡം, നമ്മൾ ഒട്ടനവധി പ്രശ്നങ്ങൾ നമ്മുടെ LSTDയും വാട്ടർ അതോറിറ്റിയും ഫേസ് ചെയ്യുന്ന ഒരു ഫീൽഡാണ്. അപ്പോൾ ഇവിടെ കൺട്രോൾഡ് ലോ സ്ട്രെങ്ത് സെൽഫ് കോമ്പാക്ടിങ് മെറ്റീരിയലിനെ പറ്റി ശാലിനി മാഡം പറഞ്ഞു. നമുക്ക് വളരെയധികം പ്രോജക്റ്റുകൾ നമ്മൾ ഒട്ടനവധി പഴി കേൾക്കുന്നുണ്ട്. നമ്മുടെ ഇത്തരത്തിലുള്ള പുതിയ ഒരു മെറ്റീരിയൽ അഡോപ്റ്റ് ചെയ്യുന്നത് നമുക്ക് IRC സപ്പോർട്ട് ഉണ്ട്. അപ്പോൾ ഇത്തരത്തിലൊരു മെറ്റീരിയൽ അഡോപ്റ്റ് ചെയ്യുന്നതിന് വാട്ടർ അതോറിറ്റിയുടെ കാഴ്ചപ്പാട് എന്താണ്? മാഡത്തിന്റെ എക്സ്പീരിയൻസ് വെച്ച് ഒന്ന് ഷെയർ ചെയ്യാം.
Okay, first of all, I thank Shalini. Very nicely presented.